ellipse and its properties, and to solve 4 equations in different cases. So, what is ellipse? At this figure, ellipse is said to be defined as a conic section that is formed by a diagonal line that is dissected a cone. To explain further, I have here a cone and scissors. We will cut it diagonally so that we can easily illustrate the shape of ellipse. And at this figure, we can easily identify the properties of ellipse.
Good morning, everyone. My name is Charles Flores, and I am your calculus buddy. We are here to discuss about the properties of the ellipse. First of all, the center. The center is the point wherein the minor axis and the major axis intersect. The major axis has 2 points which are called the vertices, and the minor axis also has 2 points which are called the co-vertices. The length of the major axis is measured by 2a, and also the length of the minor axis is measured by 2b. Here we have 2 points on the major axis. These are called the foci, and the foci are measured by the length of c. Major axis is the basis of the orientation of the ellipse. Orientation, it's the figure of graph which is either horizontal or vertical. If A is greater than B, then the orientation is horizontal. But if B is greater than A, then the orientation will be vertical.
Good morning. I'm Vincent, Ramos, your pre-calculus buddy. Now, we will try to solve some ellipse which center is at the origin. Origin will be 0, 0. And the standard form of the ellipse is x minus h squared all over a squared plus y minus k squared all over b squared is equal to 1. So, we need to substitute our center. So, it's 0. Means 0 will be cancelled. So, x squared is over a squared plus y squared over b squared is equal to 1 is our standard form. We have the given x squared all over 25 plus y squared all over 16 is equal to 1. First, we will need to find the value of a and b. So a squared will be equal to 25 and b squared is equal to 16. So get the square of both b squared and a squared. So a now will be equal to 5 and b is equal to 4. With these values, we can identify the major axis and the minor axis. So the major axis will be lying at the A, which is the x-axis. And the minor axis will be lying at the B, which is the y-axis. So major axis is equal to 2A, and minor axis is equal to 2B. So 2A will be 2 times 5 is equal to 10. The major axis will be equal to 10, and the minor axis is 2B, which is 2 times 4 is equal to 8. Using this value also, we will find the value of the focal length, which is notes as c. So a squared now is equal to b squared plus c squared. Since we're getting the value of c, we will transpose the b. So a squared minus b squared is equal to c squared. Then substitute the given. 5 squared minus 4 squared is equal to c squared. Then 25 minus 16 is equal to c squared. So 25 minus 16 is equal to 9, and we will get the square root of 9 since we're getting the roots of c squared. So c now will be equal to 3. Using also the value of a, b, and c, we can easily identify the vertices, co-vertices, and the foci. Since our major axis lies at our x-axis, the vertices will be a0 and negative a0. So the value of a is 5, 5, 0, and negative 5, 0. And our co-vertices will lie in the y-axis. So we will use the value of b. So 0, B, and 0, negative B. And the value of our B is 4. So 0, 4, and 0, negative 4. To find their foci, we will use the vertices and the focal length. So the formula will be positive and negative A plus the foci and 0. So 5 plus 3, 8, and negative 5 minus 3, it's negative 8 and 0. At this example, we have the vertices and the co-vertices. The vertices is where the major axis lie, and the co-vertices is where the minor axis lie. And our vertices is 0 and 0, and the y-coordinate, which is the B, is 5, and 0, and the y-coordinate is negative 5. So let's equate the major axis is equal to 2b, and 2b is equal to the distance of the vertices. So we will use the distance formula, which is now 2b is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we will substitute now the value. So the x coordinates are 0. So 0 minus 0 squared will be 0 plus 5 minus negative 5 squared. So this will be positive now. So 5 plus 5 is equal to 10. Now 10 squared will be equal to 100. So the square root of 100 is equal to 10, and the 10 is the major axis. So the B will be 5, since we divided by 2. And now we will get the distance of the co-vertices, which is the minor axis. So 2a now will be equal to the distance of the co-vertices. So 2a will be equal to the distance formula, square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So same as true, substitute the value. The y coordinate are 0, so this will be cancelled out since it is equal to 0. Then 4 minus negative 4 squared will be 8 squared. So 8 squared is equal to 64, and square root of 64 is 8. The minor axis will be 8, and the a will be 4. Since we're done solving the value of a and b, we will now get the value of c. And we will use the formula a squared is equal to b squared plus c squared. Since we're looking for the c, we will substitute the value of b squared. So now, our formula will be c is equal to the square root of a squared minus b squared. So substitute the value, the a. So 4 squared minus 5 squared will be 16 minus 25. So 16 minus 25 is equal to negative 9. So since we're pertaining to length, we will get the absolute value of negative 9. So the absolute value of negative 9 is 9. So get the square root of 9 will be equal to 3. And 3 now will be our focal length. Using the focal length, we will now get the foci. And the formula for the foci is 0, 0, 0 plus c, and 0, 0, negative c, because we are at the origin, or our center is the origin. So now, our foci are 0 and 3, and 0, negative 3.